All right, so last time I kind of talked about Ohm's law and gave a little bit of insight about the direction of current flow. And so we could tell from the previous example, what I was talking about here, if we know the polarity of the voltage source, then that can tell us the current direction. Well, what if we know the current direction? Well, then that can tell us the polarity of the voltage or what the node voltages are in our circuit. And so what I want to do in this example is I want to draw a circuit with a current source instead. So let's say I have a DC current source, and I have my resistor here, and I'm going to solve using Ohm's law. And let's go ahead and draw our ground symbol over here. And let's say that this is a 2 kilo ohm or 2000 ohm resistor. And let's say that this is a 1 milliamp current source, okay? And so what I had talked about in the previous slide is that if I know that I have 1 milliamp flowing here, then I also know that I have 1 milliamp flowing all throughout my circuit, right? So all around my circuit, I have 1 milliamp of current. All right, so right down through my resistor, exactly what I need is that I know I have 1 milliamp of current flowing. And if you'd like, we can even pull this little piece out of the circuit and analyze it separately, just like we were looking at in the previous slide. And now I can label my voltages. Let's do them both at the same time. So I can call this VA and I can call this VB. And then over here, that would correlate with this node being VA and this one being VB. Okay. And what I want to do in this circuit is I want to determine what is the voltage VA. Let's say that that's what the question was asking. What is the voltage VA? That's what I'm trying to solve for. Okay, so we can solve this using Ohm's law. And of course, we know that the V in Ohm's law does not talk about VA or VB, but rather it talks about the difference between VA and VB, right? And since I know the direction of current flow, I should know right off the bat that VA is greater than VB in this circuit, right? Because I know that I drew my current based on the current source, which tells me that the current is flowing up on the left-hand side of the circuit and then down on the right-hand side of the circuit, because it's going to flow clockwise through this circuit based on the direction indicated by my source, okay? And so what I need to do is I need to go ahead and solve Ohm's law. Well, I know that V is equal to I times R, so I can write V is equal to 1 milliamp times 2 kilo ohms. Well, my milli is 1,000th, 1/1000th, and kilo is 1,000, so those cancel. So I'm left with 1 amp times 2 ohms, which gives me 2 volts. Well, that's great. I found V, but I haven't found VA yet, which is what I was trying to solve for from the beginning over here, right? And so this may be pretty obvious to you, but all I need to do is say that my 2 volts V is this V, right? And that's equal to VA minus VB. And the last thing to recognize here is that my VB node, which is on this side over here, is connected to the ground node. And we know that ground indicates that the potential on that node is 0 volts. So I can say that 2 volts is equal to VA minus 0. And then, in other words, VA is just going to be equal to 2 volts. All right, so we have solved a couple of example circuits using Ohm's law, one with a voltage source and one with a current source. I feel confident that you're now equipped to tackle some problems on your own. And so following this video, I'm going to assign the first probably set of homework problems. And you guys should be equipped to solve some of these circuits now. Obviously, if you have any questions, I am available and happy to answer them. And I'm going to sign off on this video now and get ready to start the next chapter or module of this course.